Hello and welcome to Cloud Native Talks. The title of tonight's presentation is Going Serverless with Native, presented by Sebastien Goasguen. This event will proceed as follows: a short introduction, the main presentation, Going Serverless with Native, and finally a Q&A session. Now, during the talk, please post your questions in the chat so that we can collect them and then ask them in the Q&A session. My name is Marcin Krzyzewski, and I'll be your host for this event. Our speaker tonight is Sebastien Goasguen, and we will be supported by Eliza Kasperik of Knative. Please note the following upcoming events. Cloud Native and Kubernetes Tri-City regular meetup will take place tomorrow evening. On the 12th of April in Poznan, we'll have the first Cloud Native and Kubernetes meetup. There are spots available for the Kubernetes workshop in Tri-City. You can buy tickets to the Cloud Native Warsaw Conference, which will be on the 9th and 10th of September, 2019. For regular updates about the Cloud Native and Kubernetes community events, follow us on social media. You can discuss Cloud Native issues on our Slack channel. All links are in the description below the video. And now, please welcome Sebastien Goasguen with his talk, Going Serverless on Native.
Thank you very much, Marcin, and everybody organizing the CNCF event from Poland. So it's great to join you. Thanks for having me. This was supposed to be scheduled last week, and then I got sick. So thank you for rescheduling, and I'm very happy to be back. So I'm going to talk about going serverless on Knative. So you say native, I say Knative. K for Kubernetes, I guess, and then native, native cloud native applications running on Kubernetes. And we'll see as we go along in the talk how I describe cloud native applications. If we just cut it short and we could, leave the talk at that, cloud native applications to me are event-driven based applications that make use of cloud provider services. And they're developed in the cloud straight up. They make use of those public cloud services. And those services are linked together thanks to events. So that's why we say they're event-driven. Sebastien Goasguen here. I'm the co-founder of TriggerMesh, a new startup. We build a serverless management platform on top of Knative, and you can follow me on Twitter, Seb Goa. I will show you TriggerMesh at the end of the talk when I do demos about Knative. I think that's going to be the most efficient way to illustrate the current state of Knative. We build on top of Kubernetes, of course. We have a SaaS offering that you can use to deploy your functions and link your events. And of course, we do design services and trainings to help people on board with the cloud native movement and paradigm. All right. I feel quite lucky to have started looking at containers early when Docker started. I was not right there at the beginning, but when I saw that containers were getting really a lot of traction, I paid attention, and I'll come back to this. I think it's a very important thing that we have to do. We have to pay attention to new technologies. So I paid attention because I saw a lot of people use Docker and package applications with Docker very early. So I wrote the book, the Docker Cookbook. While writing the Docker Cookbook, I discovered Kubernetes because that was 2014, and I ended up writing the Kubernetes Cookbook as well with Michael Hausenblas. So few things I've done in a previous company, previous startup, Skipbox. Some of you may know of some of those software Compose, which is in the Kubernetes incubator. It was the second software in the Kubernetes incubator. I'm actually quite proud of that. Just after Helm, Compose was, just a little utility. Not everything has to be groundbreaking software. Compose is a little utility that allows you to convert Docker Compose files to Kubernetes manifest. I always say it cannot, do a perfect translation, but it gets you 80, 90% of the way there, and allows you to move from Docker Compose to Kubernetes. Also developed things like K-Machine, Cabin, which is open source mobile app for Kubernetes, and of course Kubeless. That's how I really got started into the serverless world. There are quite a few serverless framework out there built on Kubernetes. Kubeless was one of the first with Fission, but you also have Riff, which is actually based on Knative. Riff coming from Pivotal. OpenWhisk runs on Kubernetes, but is not really Kubernetes native, I would say. So Kubeless was one of the first frameworks, and I'm not gonna dive into Kubeless, but we'll look at some of those mechanisms a little later in the demo. And now in Trigger Mesh, we're doing lots of open source contribution, like the Knative Lambda runtime, which lets you package functions the same way that AWS Lambda provides their functions on their Lambda service. And Class, which is the Knative Lambda sources. So if you want to trigger a function based on events coming from SQS or Kinesis, you can use our Class event sources. So, lots of Kubernetes-based software open source. All right, that's kind of a presentation. Agenda, I kept it really simple, and you can see, I don't put too much time into doing the slides. I like to, instead concentrate on the message, the content. Really, what I want to do is actually start with some general thoughts about technology and cloud native. What is going on right now in the cloud native landscape, and more generally in our industry, in the tech industry, specific definitely to infrastructure software. Okay, so I'm gonna spend quite a bit of time on this, and then introduce serverless because it's a next development into what's going on. So we'll introduce serverless, and for Knative, what I'm going to do is actually keep it relatively simple. Once I introduce serverless, I'll dive straight into a demo, and then show you Knative from a demo standpoint. So we'll get on the terminal, and we'll look at the controllers, the pod, the APIs. We'll look at the build. We'll look at the sources. And then I'll show you how Trigger Mesh can bring all of that together. All right. So let's get started. And one of the big things that I see with customers these days is that modernizing the stack, modernizing the infrastructure, modernizing the software development lifecycle is quite complicated. Staying up to date with the new technologies that arrive every day is extremely challenging. Knowing what is going to succeed, is of course like almost like divine powers, right? It's very difficult to figure out, is this tool going to be successful and maintained and sustainable, going forward? So all the enterprises are faced with this, challenge, and I think that it's not new. Nothing is totally new. Okay, I mean, enterprises 20 years ago were faced with the same challenge. How do you evolve? How do you modernize? But I think these days the rate of change, the rate of new software arriving in the landscape has really increased. Okay, and I'll show some data to kind of show that point, right? So that's really the big question out there. How do companies stay up to date? It's very difficult because we're being bombarded. Okay, so it's I need to figure out a better picture than just planes, throwing bombs. But That's the idea. We're being bombarded with new texts, and serverless and Knative, those are some of the things that we're being bombarded, right? So we're just done with containers, or we're just, not even done, but we just get our heads around containers, fresh out of having built a private cloud, right? With CloudStack, with OpenStack, you name it. So we've just finished our cloud. Suddenly we have containers falling into our lap, and then suddenly we have Kubernetes on top of it, and now suddenly we have Knative because we need to go serverless. Wow, our heads are spinning. We're being bombarded. It's extremely difficult to make sense of, all these tools and all of those landscapes, right? And vendors, of course, they need to show us, where they fit in the landscape, where they fit into that battlefield, right? Sometimes, it actually feels like it's a real battlefield. So, I do big data. I'm in the configuration management space, and you look at those landscapes, and you're being told, hey, this is the new Docker landscape. You need to adopt and know where you are in this container landscape, and it's very, very challenging, right? I mean, how do you make sense of something like this, right? If you do, infrastructure automation, you have yet another landscape, and of course there is some overlap. And then if you do, DevOps, well, of course you have to do DevOps, and now you have API services, API management, CI/CD tools. I mean, DevSecOps, that's picking up these days. It's very difficult, right? It's difficult to make sense of the terminology. What does the term actually mean? And then it's difficult to look at all the texts that are available and pick one. Should I go with Chef, or should I go with Puppet, or should I go with Ansible? Very, very difficult, right? If you do big data, I'm like, I applaud you because the landscape for big data is just insane, right? I mean, so many tools, about big data. So the bottom line is that we have this explosion and we're being bombarded. So when we're faced with this challenge of, hey, let's modernize our stack, again, very challenging. Suddenly comes Cloud Native, and what does CNCF, start to do? The first thing they start to do is a landscape. And we all understand why they started doing a landscape, right? You need to figure out those things. But then everybody gets into that landscape, and now you have something that, what's the real meaning of this? What do you make out of that landscape, CNCF landscape? It's very difficult, right? And it's very difficult because people tell you it's the future. It's the future, you need to adopt it. So serverless is the future, Knative, it's the future, you need to adopt it, right? And I should be here advocating, for serverless and Knative. I should be telling you, you need to run Knative tomorrow, right? But we have to be very pragmatic, we have to find a way to be sustainable and to develop, our apps and manage our infrastructure at a sustainable pace, right? Yet people tell you it's the future. And there was this blog on Circle CI some time back, which is really, really nice. You should all read it. Circle CI blog, it's the future. I hope the URL hasn't changed. It's this story about, this person that wants to deploy a web app. Very simple thing. I want to deploy a web app. And that person talks to somebody who has totally drank the Cloud Native Kool-Aid. And that person starts saying, oh, no problem. You just, put your app in a Docker container. Oh, okay. What's Docker? And then, oh, well, Docker is just C groups and namespaces. Well, what is that? Oh, no problem. It's the future. Well, you just need a fleet of servers to run your containers, with Swarm. It's like, oh my God, now I need a fleet of servers. And suddenly the conversation goes on and on. And, what started with a very simple request, I need to run a web server, ends up being like a super complicated cloud native stack, right? So look at this blog. It's hilarious. It's very funny. And it is funny because it's also, half true, right? And sometimes I even catch myself writing a blog or writing a tweet or a question on Slack, and I'm like, oh man, nobody can understand what you're saying. This is total gibberish, 100% Kool-Aid, right? And people tell you it's the future, especially that social media has taken such a big part in our lives that we get fed thoughts from social media, not only about tech, about other things, but about tech. It's true. So you get all sorts of advocates and pundits and so on that say, oh, it's the future, you should adopt this, you need to move this. So I promise I'll get to serverless. And you're getting drawn to do two things. You're getting drawn to either adopt software 0 day, so 0 day software, kind of like vulnerabilities, 0 day software. So software just comes out 0.0.1 and you go to production right away because it's the future, right? So I took that term from Chris Beutert, one of the founders of the DevOps community in Europe, and it's really a problem. 0 day software, right? Going to prod. Yes, I'm in prod with Knative. No, I don't think you're in prod with Knative. It's not stable. It's changing every day. So you cannot be in production with Knative. So you're drawn to this 0 day software, and the reason why you're drawn to this is because if you don't adopt 0 day software, you feel that you're going to miss the new paradigm. And if you miss the new paradigm, you're going to struggle modernizing your IT, right? So you don't want to miss the new paradigm, so you end up adopting 0 day software, right? Very problematic. And the challenge that we are being bombarded with all those new techs. We know that some of those are going to be to become the foundation for potentially a new disruptive paradigm. So we need to figure out, is it a fad that's going to stop in a couple days, couple months, or is it a trend that's going to stick, right? And what we want to avoid is, this diagram from Simon Wardley, who does a lot of work on strategy, especially applied to IT, which is, a new tech comes in, and at the beginning, you're like, you ignore the new tech, and then you said, no, we're not adopting this. No, we're not putting this in the data center. I said no. Oh no, oh my God, Yes, everybody else has adopted it, and you're too late, and you've been disrupted, right? So you want to definitely avoid this, and it's that's the challenge, right? How do you avoid this in a world that's moving ever so fast, right? So yeah, that's like Jack Nicholson, is like, oh my God, what do I do? That's great, Sebastien, but you're not telling us what to do. What do we do? And the thing is that these folks, Uber, Facebook, Alibaba, Airbnb, whether we like it or not, whether we like their business model, they've managed to move extremely fast, and they managed to create a brand new business model that are software-based, IT-based, and they have totally changed the landscape, with their competition. Airbnb, is probably, at least to me, Airbnb and Uber are the biggest two examples of this. And then Netflix, of course, who has killed all the DVD renters, right? But Airbnb, provide just a great service to people trying to rent their places or their apartments, and Uber, of course, taxi company with no vehicles, right? So we would like to be one of those. We would like to, or at least we would like to be in the wave, to follow the movement, because we want to modernize our IT. We don't want to be caught and being disrupted, right? So that's what we're seeing, and I hope that's making sense. And I think you can see where I'm going with this, which is that serverless is exactly in the middle of this. You're hearing serverless, you're hearing Knative, and now you're scratching your head. You're like, well, do I go full serverless? Do I even skip containers? Things like this. So that's really the dilemma that we have. But it's important to know that, I mean, it's a very important question, right? If you don't do it, you may get disrupted. So before we move on, there is an interesting question. Why do I think that we're being bombarded? Why is there this explosion of tools and landscapes, right? We've had landscapes for a while. Vendors are very good at putting landscape together. And, you know, I have this little bit of a thesis here, which is what happened in 2008, right? Except the financial crisis. What happened in 2008? Well, GitHub happened in 2008. It was created in 2008. And if you look at the stats, of course, you can find them on Google, you know, and I was going to say YouTube, but Google. 2008, GitHub, 40,000 users, 38,000 repos. And then 2009 goes up, you know, quadruples. Actually, it doesn't look like in 1 year it went up that much, but actually quadrupled the number of users. Next year, you know, what is that? Times 3. Yeah, times 3 in 2009, 2010. And then what is that? You know, times 2, a little bit more, 2011, times 2 again, 2.5, 2012. And now I think they have 20 million users. 20 million users, 57 million repos. So that growth, probably not exponential, but really, really explosive growth, which means that since 2008, the world has changed, that we have access to so much more software, right? I'm not saying that we didn't have access to open source before 2008. That's not true. We had, of course, there was a bunch of ways to get open source. But since 2008 and GitHub, I would actually argue that we now have access to 57 million pieces of software that we didn't have before, and 20 million users. Depending how you count developers, it roughly means that every developer in the world is on GitHub, almost. And maybe not, probably not, but you know, 20 million is a lot of people. So this explosion happened in 2008, okay? And I would say that since that time, since 2010, you know, now we get, hey, there's this new tool, and you know, things like that effect compounded with Twitter that promotes ideas and new tools. Things like Hacker News, you know, this social aspect has really totally increased the bombardment of new tech, right? So now the thing, and that's a very important message I try to give everybody, is like, do not dismiss, right? We have all these tools, and big thing, and something that has taken me a while to understand is, do not dismiss a new tech. Okay, you may be a great engineer, you may be extremely smart, you know, have studied a long time, or not studied at all, but being extremely street smart, or being a very good developer, doesn't matter, right? Do not dismiss. Do not dismiss new tools. When you hear people saying, hey, this is great, and you know, don't be too negative. If you're too negative, you may actually miss an opportunity, and you may actually not understand, you know, something, a feature, a UX, you know, an experience, you know, a community. You may pass a community something, right? So that's actually quite big. You know, do not dismiss, and of course, do not dismiss serverless. And why I'm saying this is because that's exactly why I wrote the Docker cookbook. I was very negative about containers, okay? Believe it or not, okay? I was very negative about containers. I was like, you know, are you kidding me? We've been working on, you know, private clouds and virtual machines now for so many years. We know containers, we know they exist, we know existing container technology, we know jails, you know, things like this. And now you're telling me that we have to abandon our VMs. You're telling me that our VMs suck and we should just move to containers right now? So I was, you know, I was saying, you got to be kidding. But instead of, you know, instead of dismissing it, I said, okay, there has to be something. right? If there are so many people that are saying this is great and they're adopting it, there has to be something. So what I did, because I have big academic background, I said, okay, fine, let's write a book. So I made a proposal to O'Reilly and I said, okay, I'm gonna write a Docker cookbook. And the truth is that I wanted to learn Docker. So I learned Docker, and everything that I learned, I put it in the book, right? So do not dismiss. And while I wrote the Docker cookbook, that's when I discovered Kubernetes. For me, Kubernetes was the real answer, right? So do not dismiss. All right, you're still with me? I hope you're still with me. And I hope you find it interesting. So do not dismiss, and definitely do not dismiss serverless, all right? Especially if you hear things like, oh my God, AWS Lambda is killing it. People are going to skip containers, go straight to serverless. Forget about your private cloud. Go straight to AWS. Don't worry about infrastructure anymore. Just write code, right? So you're listening to this and you're like, yeah, okay, this is a joke. This is a joke. You cannot tell me to throw away, several years of work, and then my team that now has adopted containers for our software development lifecycle. That's a joke, right? So yes, it's a joke, but even though it's a joke, you should not dismiss the fact that there is something going on with serverless, right? And the one thing that convinced me is that I went to one of the first serverless days. I don't think it was called Serverless Days at the time. Maybe Serverless Conf London. That was 2 years ago, 3 years ago. And I went there, and very clear that there were users of AWS Lambda. It was not just marketing hoopla. There were people using AWS Lambda, and there were quite a few of them, and they were already discussing performance issues and things like this. So I was like, okay, this is definitely real, right? So do not dismiss. Do your own research, of course, and as you do your own research, you should definitely know that there is no silver bullet. That's a big thing in all this bombardment of tech. So serverless is coming. You should not dismiss it. But at the same time, I'm telling you, it's not going to be a silver bullet, right? And all of this terrible talk to try to sell you something, okay? I'm not a sales guy. I'm just giving it to you like I understand it, and I believe in it, right? So do not dismiss serverless. At the same time, serverless is not going to solve everything. It's impossible, because there are no silver bullets. No silver bullets is not something new. It's actually an academic paper written by Frederick Brooks, and he put it as an annex in the 20th anniversary of the mythical Man Month in 1995? No, the 10th anniversary then. I think Mythical Man Month was published in 87. No, or before? 75? Okay. We'll have to check the dates. Something's not quite right on my slide here. But No Silver Bullet is actually a paper written by Fred Brooks, who wrote the Mythical Man Month. And if you don't know, in the Mythical Man Month, they said the basic thing that if you're late in the software project and putting more people to it is not going to make the delivery on time. To the contrary, it's going to slow it down, right? It's actually a full paper, but No Silver Bullet is also a paper from Fred Brooks. So there are no silver bullets, and software does not come out of thin air, right? It's not just like, hey, look, I just invented Kubernetes, right? So you look at Docker, it's not like Solomon Hykes and the folks from Docker. They just didn't flip a coin or claquer des doigts, go like this with their fingers, and just said, hey, here are containers, right? We had Linux containers before. Linux containers were based on namespaces and cgroups, which were part of the kernel. Cgroups were invented by Google. So Docker didn't come out of thin air. They used the foundational work, from LXC, right? Same thing with Kubernetes. You're like, oh, Kubernetes, it's the new thing. Well, Kubernetes does not come out of thin air, and it's not a silver bullet. So you need to evaluate it. What's interesting is that you need to evaluate technology in within a historical context and knowing where it comes from. If you do this, you understand why containers, how containers came to be, like I just said, based on LXC. And actually, from a product standpoint, you understand that what LXC suffered from was really a poor UX, which totally slowed down adoption. If the LXC UX had been much better from the start, we would probably have seen much more adoption of containers before Docker. But Docker basically reinvented the UX of LXC. At least that's my view on it. Okay, they reinvented the UX, and they made the Docker Hub, which allowed people to share apps. Right, so that's what really kicked things up. But when you look at this graph from Sam Ramji, you realize that C groups come from Borg, which is the internal system at Google to manage distributed application, and Kubernetes is a rewrite in the open of Borg. So everything fits. Everything has a story, and it makes sense into a certain evolution of tech and convergence of things, right? So when we are being bombarded with all that tech, and we're going to see even more and more bombardment, we have to step back. We have to say, okay, let's not dismiss this new evolution. Let's evaluate things carefully, like we should always have done. Let's not be the victim of social pressure, because it seems totally crazy that we would choose a software stack or a software solution based on social pressure. But there are lots of emotional reaction and decisions, right? So you need to look at things calmly and understand this context. And to illustrate this, I'll get to serverless, okay? But I think this is very important. To illustrate this, at the time when Kubernetes came out, 2014, I was working on CloudStack doing VM orchestration. And I told you already how I was like very, not dismissive. I chose not to dismiss Docker, but I was very skeptical. So when Kubernetes arrived, I was like, oh, perfect. It's a cluster scheduler, quote, orchestrator, fine, because it does other things than schedule. And I was like, hey, you know what? If we could run containers, if we could run VMs in containers, we would basically have a new VM orchestrator. So I truly thought that Kubernetes was going to kill CloudStack and OpenStack, right? That's why I started, going down the road of Kubernetes, because I still wanted to orchestrate application, deploy apps, and so on. But I still believe that VMs would be an interesting vehicle. So I did a prototype, and I wrote a blog at the time, 2015, where I used KVM, because KVM VMs are just Linux processes. That means that they can run in Docker containers, and that means that they run as Kubernetes pods, right? So if you look at that blog, you can run VMs via Kubernetes. And turns out, after talking with Joe Bida, that this is exactly how they do Google Compute Engine. Google Compute Engine is basically a distributed application that runs KVM VMs in containers managed by Borg, right? So you fall back on your feet, right? If you look at tech, you take the time to look at tech, you understand where things come from, you don't dismiss new things, you totally fall back on your feet. It's like playing puzzle. All right? Still with me? Okay, good, perfect. I have no idea. I'm just looking at my screen, okay? So I don't know, if you find it interesting and how many of you are out there, but I'm being told that this is being recorded, okay? So I'm giving you everything I got. So serverless, long introduction, but very important, and I'm very happy to share, at least my my small thinking about, how we get to serverless, right? So serverless, you start hearing this, and you don't run back. You don't run screaming and swearing at everybody. You don't dismiss, right? You're like, okay, there is something. Let's take a little bit of time. Let's allocate some time, and let's try to understand what this is, right? And it does not come out of thin air, right? So AWS Lambda doesn't come out of thin air. Google Cloud Function doesn't come out of thin air. And if you stay in this thinking that every Google applications run on Borg, you're like, okay, so Google Cloud Function is a distributed application that runs on Borg, right? So the serverless offering of Google runs on Borg. So I should be able to write a serverless framework on top of Kubernetes, right? And when you start thinking about this, it makes total sense. The only bit that doesn't make perfect sense is that a core tenet of serverless is that you don't care about infrastructure, you don't manage infrastructure. That's why it's called serverless, right? Because you don't see even the infrastructure, right? And of course, I tell you, you can write a serverless framework on top of Kubernetes, but then you have to deal with Kubernetes. So, folks from AWS are gonna give me a lot of grief on this, saying you're just, talking total nonsense. It's ridiculous because you still have to operate Kubernetes, right? But, whatever. Let's move on, right? So serverless, we don't dismiss. It does not come out of thin air. And if we think about Google Cloud Function, for example, it runs on Borg. I mean, I'm guessing it runs on Borg. I'm pretty sure. I think it's a safe bet. And that means that we could write something on top of Kubernetes. And that's when, I decided to write kubeless, because there was lots of chatter on Twitter, but saying, people saying, oh, forget about Kubernetes. We can go straight to serverless, write function, write lambdas, right? So you have this social pressure. And I'm like, let's step back a little bit, right? What is serverless? It's a PaaS. It's a type of platform as a service with very small functions that we deploy. How can we deploy a very small bit of code? Well, we need to find a way to inject that code inside a container and then let Kubernetes scale it for us if we hit that function a lot, right? So that's when I started writing kubeless. Tuna, Nguyen, who was working with me at the time, he came to my house in not a garage, a basement. We sat in my basement for 3 days, not consecutively. I mean, not 24/7. It's not as romantic as it sounds in on TV. We pretty much did a 9 to 5, regular. We started writing a Kubernetes controller. We defined something at the time which was called a third-party resource. I wrote a basic Python runtime where we injected code via a Kubernetes config map, and suddenly we had what looked like a mini AWS Lambda, right? So that's how kubeless got started. And serverless, definitely they're servers. Okay, it's just a bad word, and I don't want to spend time trying to explain the term. I don't want even to fight it. We already spent too much time explaining what the cloud is. The other day, I found a talk of mine from 2009, I think. Yeah, 2008, 2009, explaining cloud, right? So that was 10 years ago. I don't want to do another talk explaining, trying to explain the term serverless, right? So let's just live with it, okay? But what is it? What are we talking about here with serverless? We're talking about application pipelines that are driven by events, okay? And all the following diagrams are taken from AWS. File processing. We dump pictures into Amazon S3. S3 emits notifications, and those notifications, trigger the execution of a function that creates a thumbnail, for example, and then the function sticks the thumbnail into another bucket, right? It's an app that's fairly simple to execute, except that in this picture, what you could take it as extremely easy is the fact that S3 scales to multi-petabyte. So you have a almost infinitely scalable storage system. That means that the pictures that you dump on there, it could be millions of pictures. And the lambdas that get triggered, it could scale to, tens of thousands, hundreds of thousands of instances of that function, okay? So you shouldn't dismiss, the scalability of this. Stream processing, Amazon Kinesis, Google Cloud PubSub, Azure Event Grid, lots of events coming, Twitter streams. Every time there is an event, triggers a function, processes that event, puts something into a database or DynamoDB, NoSQL data store. Extract, transform, and load, ETL pipelines, do an order in an e-commerce platform, creates an entry in DynamoDB. That's an event that triggers a function, which transforms the data and archives something into yet another service, right? You can go on, and IoT is also a big use case because there are potentially lots of devices out there which are going to generate a lot of events that will need to be processed. But the basic idea here is that you have pipelines. This service emits an event, triggers a function, which calls another service, which could trigger, create another notification, which could trigger another event. You have a pipeline, which, gets described as a graph, and you want to have all those bits highly scalable. You don't want to manage any of that infrastructure, right? You would like it to be, auto-scalable, and you only want to pay for exactly what you use, right? Typical cloud, capability. So characteristics of serverless, event-driven, that's the big thing. At the bottom of that list, I put functions, because a lot of people, when they start talking serverless, they think function as a service, FaaS. And if we just stick with FaaS, I think serverless is actually extremely boring, right? Putting a little bit of code on the internet so that you can call it over HTTP. We've been doing that for a long time. Some people have done CGI in a past, even with Perl, you name it. That's pretty boring, right? So if you're managing a bunch of CGI scripts served by Kubernetes, that makes it a little bit more interesting, but you could question, the sanity of it. But the real kicker is that all those functions are being called in a very asynchronous manner based on events, right? So it becomes like the, almost, I feel like the holy grail of service-oriented architecture, where you have autonomous agents that carry out functions. And those autonomous agents, while they're not fully autonomous, but they are self-contained, if you wish, and then they get activated when they're called by an event, right? So they're dormant, and then when there is an event, boom, they get activated, right? So in that sense, they're autonomous. They're self-actuated. You pay what you use. That's nothing new here compared to the cloud. That's the whole point of the cloud. You only pay for what you use. Scale transparently, and less and hopefully no infra work. That's definitely also, the cloud providers telling you, hey, if you use our services, we operate it for you. I mean, that's their core value add, right? You don't want to be operating a set of TensorFlow trainer, right? You want to use a service and say, hey, here is my data, train it. Oh, here is your model. Fine, you've created my model. No, now serve it for me, right? You don't want to be maintaining that infrastructure, okay? The reason you don't want to maintain it is because it's extremely hard, right? So I'm going to run out of time. You see, I told them I was only going to speak for 45 minutes, but I'm going to run out of time. So what do? Again, AWS is the leader. I love Google, but AWS is the leader in serverless, right? Okay, yeah, AWS is the leader. And then serverless, but really what we mean is serviceful. That term, I heard it first by Patrick Desbois at Config Management Camp in Belgium. That term is not going to stick. It's too late, but it would have been much better than serverless, right? So what do you do now? You move to AWS because Lambda is the leader. You re-architect your applications to use Lambda, or probably better to not re-architect, but your new services, you should use Lambda. And if you're truly cloud native, you go directly in the cloud. You develop in the cloud. You write glue, which is those dormant functions, and then you just define the events that are going to actuate those functions, right? That's being cloud native. I invite you to pay really attention to something that AWS just released, which is event fork pipelines. I'll leave it at that. Okay. If you don't want to do that, what do? Right? If you don't go to AWS and embrace Lambda, well, you do the same. But where do you do it? Well, you do it on Kubernetes, right? With the big benefit that you can do it on-prem. You can still do it on AWS with EKS, but now you can do it in Google Cloud with GKE. You can do it in Microsoft Azure with AKS. You can do it with OpenShift, right? So you want to do the same thing. You want to be truly cloud native with an event-driven application based on functions. You do it on Kubernetes, right? And I should really talk for 2 hours, right? How do you do this? You do this with native or Knative, okay? Knative gives you the building blocks, the software primitives, aka the API objects that allow you to build a serverless solution that runs in Kubernetes, right? It was announced at Google Next in July 2018, so it's going to be a year this summer. There are 3 components: build, serving, and eventing. I'm going to go back to this. If you look at the documentation, it talks a lot about source-centric workload, right? The reason it talks about source-centric workload, I think that from a marketing standpoint, they didn't want to say serverless, but also because if you use Lambda or GCS, the one thing that gets emphasized a lot is that you just write code, right? You just write source. We can argue about this, but the concept is I write my Go code, I write my Python script, and then I post it to an API. I send it to the serverless offering. Something's going to happen in the background. It's going to compile my code if it's compiled code. It's going to get the dependencies. It's going to create an executable artifact. That's the build step. Once that executable artifact is ready, it's going to serve it so that an event can call that function. So the executable artifact is going to be served with some very important features, which are auto-scalability up, but also auto-scalability down all the way to 0. Right? You want to scale to 0 so that if you don't use your function, you don't pay a dime. Okay? And then, of course, you need eventing. I told you it's an event-driven system. So Knative gives you eventing primitives so that you can manage those events. You can manage the sources, the event sources, and you can manage the binding between, or the mapping between an event and a function. All right? So build, serving, and eventing, just keep that in mind. It's the foundation of Knative, and that gives you serverless capabilities, right? all of this is made possible as Kubernetes extensions. What are Kubernetes extensions? If you don't know Kubernetes, those are called CRDs, custom resource definitions. It's an API in Kubernetes that allows you to customize the API server, right? When you create a CRD, you add a REST API endpoint to the Kubernetes API server. And then what you need to do is that you need to write the control loop that reconciles the observed state and the desired state. That's core functionality of Kubernetes controllers. You need to write those controllers when you define a CRD, and then you have a new system, right? So Knative is nothing else than an extension of Kubernetes that gives you the primitives to build a serverless solution, right? So just have a few minutes looking at the clock before I get, all cut off. So I'm just going to show you. I think that should be okay. That should be big enough. I'm on a Kubernetes cluster, okay? And I'm going to say, hey, Kubernetes, give me the list of CRDs, okay? Give me the list of extensions that, have been configured in your cluster, right? And you'll see that I have, how many of them? I have 88 of them, okay? I've added 88 APIs. I have a lot of them that are related to Istio, the service mesh. I have some that are related to Knative. Here you see serving. I also have some that are Tecton. That's a pipeline solution. What I'm going to do is I'm just going to grab for Knative. There you go. And if we grab for Knative, we see all the new APIs that have been added to my Kubernetes cluster. Okay, Knative is running. The API has been extended, and now I have access to things like build object, build templates. Okay, pretty clearly used to do a build, used to create an executable artifact from source. Channels from eventing group, probably something that takes care of events that are being put in a channel. Cluster build templates, okay, related to something that is not namespaced. Sources, cron job source, GitHub sources, so those are event sources. And then serving, I see objects called route services, right? So I see those objects, and I see that I have a set of new namespaces. Namely, I have Knative serving namespace. I have Knative build namespace. And most likely, I have Knative eventing namespace, right? So what you see here is that in each of these namespaces, named after the three components of Knative, I have most notably a controller, okay? So these controllers here, eventing controller, are watching the new CRD endpoints. And when we post objects to the API server, the controllers acts, right? So that's the idea of the system. So let me show you a little bit trigger mesh through the UI, which is going to give us an idea of how we use these Knative primitives, right? So I'm logging into trigger mesh, and you see that we have menu for functions, a menu for action, which is really our CI and pipeline menu, and a menu for events, right? If we go in services, I can say, hey, I want to run a function that's already prepackaged. Here I access a little catalog and node info. That's actually OpenFaz functions, but I'm going to run them as Knative services, right? So when I do this, I told Knative, hey, here is a function that's prepackaged. Please serve it for me. No need to do a build. Serve it for me. And once it's served, you see that I get a URL. And because it's served by Kubernetes, I have a pod. So there is a container behind it, but a function has been injected in it, right? So when I click on the URL, it calls the function that has just been started, right? If I want to do a function with a build, not like this, I go create service from repository, and let's say Warsaw. I can put the URL of a repository, simple app. I can define a simple message. I can add a environmental variable. When I do this, Knative is going to realize that there is some code, some source to look for in a repo, and it's going to trigger a build. Okay, we'll see if this works. Of course, we develop. Did I make a typo again? I tend to make a typo in this demo. I probably made a typo. Okay, never mind. Okay, unknown, Warsaw, revision to become ready. Okay, probably made a typo. Ah, no, here we go. It's kicked up. So what happened here, okay, is that the Knative build component has been called upon, and it needs to get the source that's in the repo, build an executable artifact, which is going to be, a container. So here we see a container build happening within the system, within a Kubernetes pod. It's using Kaniko underneath. Okay, so it's all bundled. And once it's ready, it's going to make the function available. Of course, it's a little bit slow, okay, because it needs to do a build, right? The last thing I'll show you, and I'll be very quick, and we won't finish everything, is a source. Typical source, which is not mega exciting, is a cron job source, right? And here is you're saying at a regular interval, like every minute, hello Warsaw. So every minute you're going to send the string hello Warsaw to the default event channel. Okay, so you're creating this source. This event is going to be put in this default event channel, and then you go and you define a trigger. That's really why we built this company, Trigger Mesh, because we believe that mapping events to function is going to be a key mechanism to do in cloud native infrastructure. Before we do this, I need to run another function, which is a message dumper. So that's just this function just dump its event to standard out, right? So now I'm going to do the mapping, and I'm going to say, hey, any event in the default channel, you should send it to the message dumper function. That's my event to function mapping, right? So I've done it. I've created the source. I've created the mapping. If I look at my pods, you see that my message dumper is running. I also have a pod for the cron job. Meanwhile, the Warsaw build has finished. I'm not sure why it doesn't get refreshed. So the Warsaw build has finished. I saw it. So if I click on this Warsaw, I see Warsaw, right? So the web app has been built. It has read my environmental variable, and I see when I hit that URL, I get Warsaw. That's the app. If I look at the logs of the message dumper, that will be the last thing. We should see at some point, here you go. We see the message, and if it's big enough, you see hello Warsaw, right? So now every 2 minutes, my event source, which is pretty boring cron job, is going to emit this string, and my trigger definition sends that string to my message dumper function. So now with this basic functionality, I hope you can imagine us writing very exciting pipelines. Make that an ETL pipeline, make that a data processing pipeline, make that scale all on Kubernetes, and thanks to Knative. All right. Well, that's it for me. Thank you so much.
Okay, but stick around now because we're going to do the Q&A session. You're listening to Cloud Native Talks. We're here with Sebastien Goasguen. His talk, Going Serverless with Knative. Very wonderful content. Right now, we just have a few questions from our audience. So the first question for you is there any specific size of project or company that serverless is suitable for?
I don't think so. Typically, what you see is that small companies are more eager and more agile, so that they can go greenfield. They have a brand new project, and they're gonna jump on a new technology like serverless, right? Typically, also is because smaller companies don't have the budget to have their own data center to do the infrastructure work. So it makes sense for these, smaller companies to do it. But we also see, banks adopt serverless. Okay, so it's not really a size of company. Project maybe more so at the beginning. A small project, very well defined scope, maybe one small service.
Okay, good. Next one is, could you elaborate on the granularity of the services? Example, best practices.
Yeah, so I'm not quite sure about this question, but I would say it's still early. So best practices, have not yet formed. We have best practices for managing, I would say, microservices in Kubernetes, but in for serverless and especially on Knative, I think it's too early still to be talking about best practices.
Okay, here's question number 3. You consider AWS as the leader, but what about the ongoing specs like cloud eventing and vendor lock-in?
Right. So cloud events is so it's not a standard. It's a document that's been written by the CNCF serverless working group, and they defined the spec for an event. And the idea is that all the cloud providers would actually emit events in the cloud event spec, right? Because right now, all the events in AWS or Google have different type of specs, so it's a little bit of a nightmare to manage them. So that's what cloud event is, and it's definitely a common ground for all the vendors to rally and create this spec, right? So definitely cloud eventing helps with vendor lock-in, if you wish. Now, yeah, I definitely consider AWS as the leader, and yes, being an open source guy, I'm at the same time I'm totally fascinated by what AWS is able to achieve and ship and make available to their users. So I'm fascinated. At the same time, I'm a little bit scared for everybody else who may not want to get on AWS because Lambda is not open source. You get tied to AWS services. So definitely there is some challenge there. That's why with Trigger Mesh, what we really push forward, are event sources that from all the clouds, multi-cloud, right? And then you can use these event sources to trigger functions that could be running anywhere, right? And I think that's going to be a new world, a new step in the type of hybrid cloud infrastructure.
Okay, so you've sort of answered the 4th question, but I'm just going to ask it and let me know if it does spark any other sort of connections to what you just said. The next big thing after serverless, what is it going to be? Nano services? Any ideas of what we can expect?
Yeah, difficult. I don't predict the future, but definitely, if you're an infrastructure guy like me, if you've done cluster management, low level, stuff, it's getting harder and harder, I find. And then when you look at the application stack, like for example, spend a week trying to do machine learning, right? And you need to set up, training with TensorFlow and then serving. You need something to scale that. You need to expose it through secure endpoints. It gets very complicated, right? So even though you're an open source person, when you look at the offering of a cloud provider, you get very tempted because the cloud provider just save you a ton of time, right? So I don't know what's going to be the next thing, but I know that there's going to be more public cloud. We're going to use more public cloud. It's going to be more pervasive. It's definitely going to be going in that direction.
Awesome. Okay, here's another one. Any ideas for dependency management between versions of deployed functions?
Yeah, so Knative has a nice way to define revisions. So a service has multiple revisions, and then you can split traffic to different revisions. So that helps you to manage those revisions, those versions of a function. But in terms of dependency management, again, you can take a clue from AWS, which has created AWS layers, and those layers allow you to reuse libraries and dependencies across functions. That's not something that's yet in Knative, but I think it will happen fairly soon.
Here's another one. I believe in #serverless, but current implementations are too simplistic to be interesting. They ignore the hardest problem of distributed computing, which is state management. Can you relate? And I think, hold on, let me make sure that that's the question. Sorry, can you relate to this statement?
Yeah, well, I think you can do a lot with stateless. You can do a lot of pipelines, like the ones that I've shown that they don't have a state. They just transform an event. They just process. But definitely in Knative, you don't have something like step functions that you have in AWS, which are better at handling state in some sort of way. So it's not yet there. That's true in open source serverless solutions. But I know someone who has developed a clone of AWS step function.
All right. Thank you, Sebastien. It doesn't look like we have any other questions. The talk was amazing. We are here tonight, again, with Sebastien Goasguen. Cloud Native talk was titled Going Serverless with Knative. Do you have any well wishes for us or anything that you want to say as we end this webinar?
Thank you all for listening. I hope you found it interesting. We're looking, we're hiring for Trigger Mesh. We're looking for contribution in the everything that we have open sourced, our AWS. If you want to play in that field, definitely reach out. Look at our GitHub, github.com/triggermesh. We would love to get some contribution from Poland. And I was in Warsaw a year ago. I really liked it. So you have a great city, and great to have you in the European Union at the time that the English are trying to get out.
Awesome. Thank you very much. Okay, well, we are closing out here. Cloud Native Talks. Catch us for Cloud Native Talks number 5. And good night.
Bye-bye.